4 in the textbook, 3.84. So I actually did the first part of this problem. It says, write an equation for the reaction of ammonia, right? Ammonia, sulfuric acid, and forms ammonium sulfate. So I kind of write it down the same way I would if I had the formula, but I don't. So I write it down with the two reactants and the product, and then I have to find out what the formulas are. So you can easily look those up if you don't know them. So here are the formulas. A balanced reaction. I'm not going to show you how to balance this one. It's fairly straightforward, but it's a 2 ammonia to 1 sulfuric acid and 1 ammonium sulfate. Next part of this question says determine the starting mass. Determine the starting mass in grams, it looks like, of each reactant if 20.3 grams of product is produced, and we have some, so watch what I do here, grams, and then I'm going to have some leftover. So 5.89. Right, so 5.89 is our leftover amount. It doesn't tell us how much we started with. So that's one of the things that we have to do here. We have to find out, well, how much did we start with? And if there's leftover, it also tells us something specific about that compound, which is the sulfuric acid. It tells us that that's the excess. And that if sulfuric acid is the excess, let me write that in there. If sulfuric acid is the excess, then that must mean that the ammonia is our limiting reagent. And again, why? Because we have leftover reactant. If we didn't have leftover reactant, we wouldn't know that that was the excess. But it's telling us that it is. All right, so how are we going to go about doing this, especially since they have the number of grams? So remember how I say everything goes back to the mole. So we're going to have to figure out how much of a mole we have. And the one that is going to drive our answers are this right here. Because we know we're producing 20.3 grams of that ammonium sulfate, we need to turn that into moles. So again, I'm not going to show you how to convert grams into moles, but we're going to be using the molar mass. So the molar masses of this product right here is that. The molar mass of our sulfuric acid is 98.079 grams, and the molar mass of my ammonia is 17.031. So I'm going to need that, and I'm going to need that because I need to turn that 20.3, in essence, it's turning it into moles, so I'm going to divide that by 132.14, and it tells me that the number of moles that I get, let's do this in a different color. Let's go with some orange here. Actually, let's go red, since our balanced reactions were red. So we actually have the number of moles of 0.15, and since they gave us 20.3, I want 3 decimals. So 0.15, I'm going to go 4 since it's 3/6. So that's how many moles this 20.3 grams is. And that's really important because I do know that in a balanced reaction, it's a 2-to-1-to-1 relationship. And if I was able to make 0.154 moles, then that means I must use, now this is in a perfect world, 0.154 moles of my sulfuric acid. Again, I have to use that. Not that I have that. I have to use that. And the other thing is I have to use, since it's a 2-to-1 relationship, twice the number of moles. So I'm going to take my 0.154 number and I'm going to multiply it by 2. And I must have used 0.307 moles of my ammonia. And again, it tells me that, hey, I used all of those moles up. So whatever 0.307 is in grams, I used them all up because it's my limiting reagent. Well, the nice thing about doing this in moles is we could use that balanced reaction. So now we have to because the answers are in grams that we're looking for, we have to turn these moles into grams. And now I'm going to just use my molar mass. So my molar mass for ammonia. So if I'm trying to figure out, in this case, moles into grams, I'm going to multiply 0.307 by that 17.031 number. And the number of moles that I must use, and this is what I'm going to do in orange. This, let's moles. Okay. So let's do some red arrows down. Let's turn these all into grams, and you'll see what happens at the end. So I have, when I do the calculation, so 0.307, so it's less than a mole, so it's definitely not going to be 17.031 grams. It's going to only be 5.23 grams. That's how much I must have used of my ammonia. That is 0.307 moles. And I'm going to do the same thing for my 0.154 moles. So what is 0.154 moles? If 1 mole is 98.079, so 98.079 times my 0.154, and it tells me that that's 15 moles. 15.1 moles, grams. And I need to add it to, I should put grams in here. I should have added to my leftover, or I should add my leftover to it. So I'm going to add that leftover of, so I'm going to go plus 5.89. So I must have started with about, I'll do this in orange. I must have started with about, since I know I used 0.154 moles, which is 15.1 grams, and then I had some leftover that didn't get used. So I must have started with somewhere around 20.99. So I probably should make this 21.0 grams. Must have started with 21.0 grams of my sulfuric acid. And look what I end up doing here. So if I take my 132.14 and I multiply it by my 0.154 number, and not surprisingly, I'm back at that original number. So what I did was, originally we took our mass given, we turned it into moles, and then I turned my moles using my molar mass back into grams, and it just proves that 0.154 moles is 20.3 grams, and that's what we started with, and we couldn't have done this if we didn't have that particular number. So the moral of the story here is balance reactions, first thing. Next, if given grams, you're going to have to turn into moles, which you then may have to turn back into grams. And that was that last.